All right, welcome to day 2 of solving one-step equations. Yesterday, you filled out this left side. Okay, today we're going to be looking at the right side problems, okay? So at the top, the first one you have is 15 plus a equals negative 11. All right, yesterday we already talked about what you see you need to do the inverse of, okay? We're trying to get this variable alone to say a is equal to something. So to do that, we use our inverse operation, okay? So we see addition, so we're going to do the inverse, which is subtraction, all right? So if I'm going to subtract 15, positive 15 minus 15, those get canceled out, all right? And we have to do the same thing on both sides, okay? So I'm going to rewrite minus 15. Okay. Negative 11 minus 15. Think back to your integer rules. Okay. If I have a negative 11 and a negative minus 15, remember minus and negatives are the same symbol, same thing. Okay. Box your numbers with the symbol to their left. All right, and now we have negative 11 and negative 15. Same signs, add and keep, different signs, subtract. So same signs, negative and a negative, we're just going to add and keep, okay? So this will be 11 plus 15. That's 6, that's a 2. So this is 26, and we're going to keep the sign. So we're going to say a, because it's all the only thing over here, equals negative 26. Okay? Same signs, add and keep. All right, and let's check it, because equations mean that a has to equal something. It can't be substituted. So we said a is negative 26, so I'm going to rewrite this. So we had 15 plus a, which we think is a negative 26. Okay, equals negative 11. So let me come over here and check. All right, I'm going to box my numbers with the sign to their left. This 15, there's nothing, so it's positive. This 26 goes with the negative. All right, same signs, add and keep, different signs, positive and negative, subtract. 26 minus 15 leaves me with 11. Okay, the sign of the higher absolute value would be that 26, so it would be a negative 11. So this is right, okay? All right, so A does equal negative 26. All right, moving on down. The next one, you see negative 4 minus negative 18 plus y. One more time. You see negative 4 equals negative 18 plus y. So remember, we're trying to figure out what the variable is equal to. You could think negative 18 plus what would give me negative 4. Okay, to solve that, we're going to get that variable alone by using an inverse operation on both sides. Okay, what you do to one side, you have to do to the other. So what do we see? Well, I see a negative and a plus sign. I see them both. So what you have to do is you have to pick. You are picking the operation and sign that is going to get your number away from your variable, okay? I don't want to subtract y, okay? That addition goes with y. This is subtracting an 18 from something, so that means I need to add 18 to get the number away. So I see subtraction. Negative signs and subtraction are the same thing, used in different cases. So this negative, I see that subtraction on my number. So I'm going to do addition to get rid of it. And I'm going to do it on both sides. Okay? All right. So a negative 18 and a positive 18, they make 0 pairs. So this cancels out. All right? This equals 0. So all we have left on this side is the y. So we have a positive y equals negative 4 plus 18, because whatever you do to one side, you have to do to the other. So negative 4 plus 18, okay, sorry, we saw subtraction, so we're doing addition. All right, so I'm going to rewrite it. We have a negative 4 and a positive 18, okay. I have no double negatives. That means you can just box the symbol in front of the number. So negative 4, positive 18. Same signs, add and keep, different signs, negative and positive, subtract. 18 minus 4 leaves me with 14, okay? And we're going to keep the sign of the higher absolute value. The one farthest away from 0 is the positive. So this is going to be a positive 14, okay? So, and you can write this either way. It does not matter what side of the equal sign you put them on as long as you keep the groups the same. So I could write this 14 equals y. I could also write it y equals 14. The statement doesn't change anything, okay? All right, let's check our answer. We say y is 14, so I'm going to plug it in. So our problem was negative 4 equals negative 18 plus y, which I'm saying is 14. All right, again, we have integer rules, so let's go. I have no double negative, so I can just box my numbers with the sign to the left. Okay, I have negative 18 and a positive 14. Same signs, add and keep, different signs, positive, negative, subtract. 18 minus 14 gives us 4. Okay, if you're not sure, you can write it out. All right, it does give us 4. And you keep the sign of the higher absolute value. The number farthest from 0 is that 18. So it will be a negative 4. So this is true. Y does equal 14. Okay, moving on down. All right. We have 6.4 touching our in. Remember, if you have something touching the variable, that operation is multiplication. So we see multiplication. We're going to do the inverse, which is division, all right? So I'm going to divide, and remember, a form of division is writing it like a fraction. Fractions are forms of division. So I'm going to divide by that 6.4 on both sides. Remember, what you do to one, you have to do to the other. So I'm going to divide both these by 6.4, all right? 6.4 divided by 6.4 just gives me 1. So this is canceled out, okay? So when we added and subtracted, remember, we got zeros. Negative 18 and a positive 18 make a 0 because 0 plus y is just y, all right? So when you add and subtract, you're canceling out to make zeros. When you divide or multiply, when you cancel out, you're getting ones because 1 in is the same thing as just writing in. If I got a zero in, okay, if I wrote that with my in, oh, that looks like a word, but 0 in would be 0 times in, that would be 0. That wouldn't even be in anymore. If I have 1 in, okay, 1 times in is just in, okay? Multiply or divide, you're just canceling out to that 1, which will just give us in. Okay, so now we have in equals whatever 46 800ths divided by 6.4 is. At this point, I need you to get some graph paper so that we can do this decimal on graph paper. All right, you have 46 800ths being divided by 6.4. Remember, the number being divided goes inside. I've already set up my top-bottom chart just like you should. Whatever number on top is, that's what we're multiplying by. So 64 times 2 is 128, and that's what you'd subtract. Okay, make sure you do these before you start. So first things first with decimals, we need to move that decimal to the right one. Okay, it gets all the way to the house, and whatever we do on the outside, we mirror on the inside. Math has a lot of mirroring, just like what we do. What we do on the left for equations, we need to mirror on the right. All right, so now we have 64 goes into 460 8/10. Remember, you carry that decimal up to its new spot, and that's done. Okay. So logically, 64 cannot go into 4. 64 cannot go into 46. I'll use my top-bottom chart to figure out 64 goes into 460. Let's see, 7 times, because that's as big as it can go without going over. So 64 can go into 467 times. Okay, 64 times 7, my top-bottom chart helps me remember that's 448. Okay, so subtract. Okay. And 0 minus 8, we can't do that without getting negative, so we're going to borrow. We have 5 and a 10. 10 minus 8 is 2. 5 minus 4 is 1. 4 minus 4 is 0. Okay, so now I have 12. All right. Next, I need to carry my 8 down. 64 goes into 128. Ooh, exactly 2 times. Thank you, top-bottom chart. Okay. After you subtract, you have nothing left. So this is equal to 7.2. Let's go back to our journal. All right, in your journal, we just figured out n should equal 7.2. All right, let's check that. If we say n is 7.2, I'm going to rewrite this. So I have 6.4 times n. So I'm going to put this in parentheses this time, or you could write times. 7.2 equals 46 800ths. We're going to see if this is true. Okay, so I'm going to go do 6.4 times 7.2 on my graph paper. So go back to graph paper. All right, and we'll solve. 2 times 4 is 8. 2 times 6 is 12. Okay, moving over place value, so I'm going to add that placeholder 0. 7 times 4 is 28, so my 8 goes down. That 2 comes up to the next place. 7 times 6 is 56. Nope. 7 times 6 is 42, plus 2 is 44. All right, now we'll add 8 plus 0 is 8. 2 plus 8 is 10. 4 plus 1 is 5, plus 1 is 6. And then that 4 has nothing to add to it. So our answer is not 4,608. We are missing our decimals. And remember, when you multiply and divide, you don't just drop it down. That's when you add and subtract, because you line them up. But here, I've moved over 1 place, 2 places. 1 plus 1 is 2. So I'm going to move my bottom one down 2 places. So my answer is actually 46 800ths. And look at that. That's exactly what we got. So this is true. All right, let's move on down. All right, last problem. I see negative 60 equals, I'm going to draw my railroad track, separate those two sides, r over 1.2. Okay, remember, if you have something written like a fraction, r over 1 2/10, the operation being used here is division. Okay, this is a form of division. All right, so if we see division, we're going to do the inverse, which is multiplication. Okay? So I saw division. I'm going to come do multiplication. So I'm going to come do times 1.2. Okay? And those cancel out. Because remember, this is just like doing reciprocals. 1 over 1.2 times 1.2 over 1. They all cancel out to 1. So now I just have r by itself, which is what we wanted. But whatever we do to one side, you have to do to the other. So we're going to come and do negative 60 times 1.2. All right, so off to the side. We don't need to go to graph paper for something this small. All right, times 60. 0 times anything is 0, so we got that twice. All right, moving over, we have a placeholder 0. 6 times 2 is 12. 6 times 1 is 6, plus 1 is 7. All right, now we add it all up. Right now I have 720, but I know that's not quite right. I'm missing this decimal. I only have it in one of my problem. I'm going to move it back over that one space in my answer. So this is 72, but I did it times a negative. So remember, with those, we use our triangle. Okay, we have our little plus sign Christmas tree topper and our little negative legs. All right, we use this whenever we multiply and divide, not the song. So I had a negative and a positive, so that means my answer has to be a negative. Okay, so that r has to be a negative 72. and then we're going to check. So let's plug it back in and see if we're right. We have negative 60. Remember, it doesn't matter if you flip it. R is equal to negative 72, and negative 72 is equal to R. So rewrite negative 60 equals R, which I'm saying is negative 72, over or divided by 1.2. Okay. All right. So on graph paper, we're going to do negative 72 divided by 1.2. Okay. So 72 is being divided by, so it's on the inside. I already set up my top, bottom, all of my multiples of 12. Okay. Because we have the decimal here, we need to move it 1 over to the wall, get it out of the way. So this is now a 12. And since we don't have a decimal in here, we know it's just at the end, and we still have to move it over that one, okay? So I made a space here. We're going to fill that in with a 0 and carry that new decimal up to the top. All right, so now we're doing 720 divided by 12. Okay, using my top-bottom chart, 12 can't go into 7. It can't go, yes, it can go into 72. It goes into 72 exactly 6 times, okay? Minus exactly 72 leaves me with 0, but I still have a number. I'm going to use it. Okay, 12 goes into 0 0 times. So 720 divided by 1 2/10 is 60. Okay, so far so good. Now we need to decide the sign. We did a negative and a positive, so that means my answer is a negative 60. So this is true. Okay, remember, draw your railroad tracks. Whatever you see, you do the opposite of to cancel out. Do it on the other side to figure out what your variable is equal to.